Okay, the plan for this video was initially to look at applying the product rule between three overlapping events. However, on second thought, I think going through this case would be a little too complicated at this point in the playlist. So later in the playlist, after we've gone through permutations, combinations, etc., and worked some example problems, we'll come back to this. Again, applying the product rule between three or more overlapping sets, where in the previous video we looked at that case for two overlapping sets. However, in this video right now, I thought it would be a good idea to do an example problem that involves finding values within overlapping sets like this, just to give you a sense for how you can use what we derived a couple of videos ago about the number of elements in A, union B, union C, union D, etc. Okay, so the problem is we're told that there's 1,109 students at a certain university who have taken a language course in either French, Chinese, or Spanish. That's the first thing we're told. Okay, so I'll say it again. We're told that at a certain university, there's 1,109 students that have taken either French, Chinese, or Spanish. And that's what these circles correspond to. Anyone within the French circle has taken French, is one of these students that have taken French. And same with Chinese and same with Spanish. So with that first piece of information, what is that telling us about these sets? Again, the fact that there's 1,109 students that have taken either French, Chinese, or Spanish, or some mixture of two of those or all three. Well, that tells us the value of, so the number of elements in F union C union S. That's exactly what that tells us, right? Why is that? Because the union of sets is everything in every set, not including duplicates. So the total number of students that have taken French, Chinese, and Spanish, either just one of those or some mixture like French and Chinese, or Chinese and Spanish, or French and Spanish, or all three, the total number of those students is 1,109. That's what this union means. Okay. Now, we're also told that there are 796 students who have taken Spanish, 285 who have taken French, and 97 who have taken Chinese. So what does this information tell us? Okay, so notice I didn't say that there were 796 students that have taken just Spanish. The statement is there's 796 students that have taken Spanish. So that's everything within the Spanish circle. So what that means is the number of elements in Spanish is 796. And the number of elements in French and Chinese were 285 and 97. Okay, now we're also told that 42 students have taken both Spanish and French. 15 have taken both French and Chinese, and 17 have taken both Spanish and Chinese. So what is this telling us? Let's start with 42 have taken a course in both Spanish and French. Is that telling us the number of elements in S union F? So that would be all of these students. They've taken a course in both Spanish and French? No. This is referring to students. Remember, these circles refer to, if you're a student that has taken French, then you're in this circle. If you're a student that has taken Chinese, then you're in this circle. So what we were told is the number of students who have taken both Spanish and French is 42. That's referring to this region. Any student in this region has taken both Spanish and French. So that is F intersection S, the number of elements, 42. Okay, both French and Chinese, F intersection C is 15. Okay, and then Chinese intersection Spanish is 17. You can also note that with these operations, the order doesn't matter. F intersection C and C intersection F are the same. I mean, this isn't the case in all set operations. If you're subtracting sets, the order matters, but for the intersection and the union operations between sets, the order doesn't matter. Yes, that's important to note. Again, when it comes to any kind of intersection or union between two or more sets, the order doesn't matter. We could do F intersection S, intersection C, etc. The order doesn't matter. Okay, so now the question is, how many students have taken all three courses? How many students are in this region? And what we can do is apply the set union intersection sum formula that we learned a couple of videos ago. Now, what you can think about is you can apply this formula into any kind of circumstance involving an intersection of sets like this. It doesn't have to always be that you're solving for the intersection of all three sets. Maybe you have the information about the intersection of all three sets, and you're trying to find this value or this value out here, right? So you can use this in any way you want. So the formula is that we've got F union C union S, the number of elements, and F union C union S. You first sum number of elements in S plus number of elements in F plus number of elements in C. Now then we subtract F intersection S, F intersection C, C intersection S, and then we add F intersection C intersection S. Okay, and remember a couple of videos ago we talked about the general union formula, how this formula works if you want to get the union of 5 sets, 6 sets, whatever. And again, it's not like you have to be solving for the union of all the sets or the intersection of all the sets. You could use this for any circumstance. Maybe you want to find this. As long as you have the necessary information, you can. Okay, but in this case, we're solving for this. So F union C union S is 1,109. Okay, S, the number of elements in S, F, and C, 796, 285, 97. Okay, F intersection S, F intersection C, C intersection S, and then plus okay. So let's add, 796 plus 285 plus 97 minus 42 minus 15 minus 17, 1,104. So, okay, so 1,109 is equal to 1,104 plus F intersection C intersection S. So F intersection C intersection S, the number of elements we can see is 5. Okay, and that's it. And we could actually fill this out. So this is 5. Let's see. F intersection S is 42. So This is F intersection S, right? Total 42 students. Well, there's 5 here, so 42 minus 5 is 37, right? F intersection C is everything here, so 15 minus 5 is 10. C intersection S is everything in here. 17 minus 5 is 12. Okay, so now you've got everything in S is you have 796 is everything in S. So what we need to do is take 796 minus 37 minus 5 minus 12. And now, so this is 742. Just this region. That would be, in set notation, that would be S minus F minus C. Okay, now let's see. Take 285 minus 10 minus 5 minus 37. 233. Okay, and then do 97 minus 10 minus 5 minus 12, and you've got 70. So now you have the number of students that have taken just Spanish, just Chinese, and just French. You have all the information you need.